Hey folks, since in all our previous session we have done lot of featureization, lot of data analysis, lot of data pre-processing and lot of stuff. In addition to that, we have also built our machine learning model with respect to our random forest classifier. Along with, we have also built our something known as logistic regression. And we have come up with the accuracy probably close to, if I'm not wrong, probably close to 80% with respect to random forest classifier. But one thing that you will notice is whatever model we have built with all these default parameters. We haven't customized the value of all the parameters that we have. So in this session, what we have to do is we have to hypertune the model using two approaches often known as randomized search CV and grid search CV. Again, for those of you who do not know what these approaches are all about, kindly check out the previous video which I have explained with respect to both the approach. So in a nutshell, let's say if I will press Shift plus Tab over there, you will end up getting all the list of the hyperparameters that you have. Again, this is typically the hyperparameter. It means you can customize the value of this hyperparameter depending upon the use case that you have. Similarly, with respect to your criterion, with respect to what is the maximum depth of the tree, the minimum samples that you need in order to split the node. That's what these parameters stands for. Again, for those of you who are not aware about what this random forest classifier is all about, kindly check out the videos with respect to random forest as well. So let's say with respect to, let's say, an estimator, imagine an estimator. So I will say, let's say this is my parameter 1. So I will say parameter 1. So we can think of storing all the data in my dictionary. I will say dictionary. So let's say key is my parameter 1. And I can say, hey, can I store some list of value with respect to some parameter 1 or some possible values with respect to parameter 1. Similarly, with respect to some parameter 2, let's say maximum depth or let's say minimum sample split. Hey, can I store some set of possible values? Similarly, parameter 3, so on. Again, it entirely depends upon your laptop configuration, your system configuration, lot of stuff. Because if you have more parameter and more set of possible values with respect to that parameter, of course, it will take more time in your execution. Hence, for those of you who do not have good specification system, it's good to consider few parameters and good to consider some few set of values and try to hypertune the model. Again, for those of you who had good specification, it's good to go with some more set of features. So you can think as some parameters over here. So the first and foremost is all about my number of estimators or the number of trees that you need in order to build your random forest. That's what my an estimator says. Similarly, we have something known as, if I'm not wrong, we have something known as maximum feature. We have my maximum depth. Again, maximum depth is all about nothing but a maximum number of labels in a tree. Similarly, we have something known as criterion. It means what is a strategy in order to build a decision tree, which is all about, hey, by default it is something known as Gini index. It means internally it uses Gini index just to build a decision tree. Similarly, if I have minimum samples split equals to true, which basically means the minimum number of the samples required to split a node. Similarly, we have maximum features. By default, it is auto. Again, we have lot of possible value. Let's say log 2, square root, cube root, lot of stuff. Again, in a nutshell, it's all about the number of features to consider at every split. That's what it stands for. So let's try to hypertune the model. Of course, by just creating dictionary, first and foremost, we need to store all the data in the form of dictionary data structure. So first parameter, let's say number of estimators. Sounds good. So what I will do is I will say, hey, can I store some possible values in my number of estimators? So let's try to use something known as a list comprehension over there. So what I will do is, let me show you one more thing. First and foremost, let's try to import something known as NumPy. So I will say import NumPy as NP. Sounds good. Using NumPy, can I call an inbuilt function, which is all about a line space? This is that inbuilt function. Let me press Shift plus Tab. It says, hey, what is the start value? What is the stop value? And the total number of the values that you need in the array. Again, by default, it typically returns the array where my values are basically equally spaced over a particular interval. That's what this function will do. So I will say, let's say, hey, my start value, let me press tab over there. This is the start. I will say start is all about, let's say, 200. Similarly, let's say and is all about, imagine 2000. Again, for those of you who do not have good specification, it's good to consider the last value of your num parameter. I will say it is all about 5. And the moment I will execute this line of code, again, if I'm not wrong, I think it is stop parameter. Yeah, my bad. It is stop. So what I will do is I will say, hey, it is stop. Let me execute this line of code. This is what you will end up getting. Look at this. As I have said, hey, can you return 5 values that are equally spaced between a interval of 200 to 2000? So this is what you will end up getting. Now let's try to store it somewhere else. So again, the moment I say, first and foremost, I need to convert each and every value in the form of integer format. So I can say just access each and every value, just call a integer on top of that. Just call an integer. Sounds good. And if I will execute this line of code, this is what you will end up getting. Let's store this somewhere else. So I will say these are all code. Let me replace all code with this one. Sounds good. Let me execute. If I will say an underscore estimator, if I will execute, this is what you will end up getting. Similarly, if I will say max underscore feature, let me cross check the parameter, which is all about, let me cross check. Yeah, it is, yeah. By default, it is auto. Let me go through into its entire documentation. Let me scroll it to below and look at this. We have the 3 possible values. It can be auto, it can be square root, it can be log2. And in different scenarios, it is good to use all the different values. Again, if it is auto, then maximum feature is all about this. If it is square root, then maximum feature is all about this. Similarly, if it is log2, then maximum feature is all about this. That's what it stands for. So what I will do is I will say, hey, maximum underscore features is all about all these set of values. Sounds good. Let me execute it. Similarly, we have something known as maximum underscore depth. In a nutshell, the maximum underscore depth is all about the maximum number of labels in a tree. So what I will do is I will say, hey, for x in numpy dot line space, my start value is all about nothing but, let's say 10. That's a 10. And let's say stop value is all about, let's say I have to stop it at 1000. And let's say I need 5 or 10. Let's say only 5. Sounds good. Similarly, I can say, hey, can I call a integer on top of each and every x? Let me store it. And the moment I will print it, so you will end up getting such amazing list. The similar stuff you have to do, but with respect to, let's say, minimum samples split, or we will say as minimum samples split is all about, let's say, some possible values. Let's say 2, 5, 10, and let's say 40. Let's say these are the set of possible values that you can think with respect to your minimum sample split. Again, in a nutshell, minimum sample split is all about the minimum number of samples that you need in order to split a node. Let me execute this line of code. Similarly, my minimum samples, let's say leaf. Minimum samples leaf is all about, imagine 1, 2, 4, 6, 8. Again, below 10, it is good to consider all the set of possible values, but let's pick the 5 values. So let me execute this line of code. Now we have to define a dictionary. Imagine dictionary name is, let's say, random underscore grid. Random underscore grid. Here we have to mention all the stuff in the form of key value pair. The first key is all about nothing but an estimator. This is the first key. So I will say an estimator, my key, and the value is all about all the values inside that list. This is what it says. Similarly, my second key is all about nothing but maximum underscore feature, which is all about this one. So I will say it is nothing but maximum underscore features, and it will store all the values of maximum underscore feature. Sounds good. Similarly, the third one plays a very vital role, which is all about maximum depth. I will say maximum depth is all about maximum depth. Sounds good. Similarly, we have an interesting parameter which is all about minimum samples split. I will say it is all about this. Similarly, this. Similarly, last one is all about, let's say, minimum samples leaf. So I will say it is all about this. It is all about this. And let's try to consider some more hyperparameter. Again, one of the interesting one is, if I'm not wrong, it is criterion. Let me cross check that. Yeah, criterion. Let me scroll it to below just to go through its entire documentation. Look at this. It uses a Gini index. The second is all about the entropy, just to build the decision tree. So these are the two set of values that you can think with respect to a criterion parameter. So I will say, hey, inside this criterion, can I mention all these set of values, which is all about Gini and entropy? Sounds good. Let me execute this line of code. And if I will say, hey, can I print whatever random grid we have? So my bad. Just because of the typo, we will end up getting such error. Sounds good. Let me execute. This is what we will end up getting. This is the key. These are the set of values. This is the key. These are the values. Again, this is the key, and these are all the set of possible value. That's what this dictionary says. Now we have to just pass this dictionary to my randomized search CV and we are done. So in the next session, what we will do is we will try to implement the randomized search CV and grid search CV, of course using Python. So that's all about this session. For those of you who have any doubt, feel free to utilize the Q&A as much as you can. That's all about it. Thank you. Have a nice day. Keep learning, keep growing, keep practicing.